guys, this is Mo. This is 9.2. In 9.2 we talk more about probability and these weird things called tree diagrams, but the tree diagrams are probably the hardest part. Other than that, it's not that big of a deal. Okay, first of all, when we're talking about probability, an impossible event is when you get a probability of 0, or if we're talking about percents, it means 0%. So maybe the probability of a dog having kittens. That would be an impossible event because it's not possible. It could never happen. And the probability would be 0 or 0%. A very likely event is the probability is high. If you have a fraction that they give you, it equals a decimal that's close to 1. For example, if we say the probability is 8 over 9, if I were to come up with a decimal for that, it's 0.88, and that's really close to 1. So that would probably be a very likely event. Whereas if we had 1 over 3, 1 over 3 is 0.33, and that's not a decimal that is close to 1. Okay. Very unlikely event means the probability is low, as in the fraction equals a decimal that is close to 0. For example, maybe 1 over 9. If I do 1 divided by 9, it gives me 0.11, and that's really close to 0. Whereas if I do 9 over 10, that's 0.9, and that's way closer to 1. So this 9 over 10 would be an example of a very likely event, and the unlikely is whatever's close to the number 0. Okay, a certain event is the probability is 1. For example, your ballet teacher wears a bun in her hair, because when you're in ballet class, you always wear a bun in your hair. So that probability would be 1. And another way to say 1 is 100%. So, yeah. Okay, let's talk about a tree diagram. A tree diagram is kind of like what you did when you were in like 5th grade, where you had a number and there were little branches. Remember, like you had 32, and then that was like 8 times 4, and then there were branches. Remember these things? They're called tree diagrams. Well, that's what we're going to do, only they're going to go sideways, and they're not going to be pretty. Okay, a tree diagram displays all the possible outcomes, like maybe you have a heads and a tails, or a tails and a heads. It tells the differences between those two. And then each outcome is a separate path, and you multiply along the paths for probabilities. Okay, let's look at this part A. It says a box contains 5 white balls and 4 black balls. Okay, how many balls are there total? Well, 5 plus 4 is 9. Okay, so that 9, the total we learned in the last section, is going to be the denominator. Okay, so we're saying that there's a box. Pretend this is my box. And here's my box, okay. And there's black balls in it. And there's white balls in it. So I have black and white balls in here, okay? And there's 9. It says a ball is drawn at random from the box. So these are random. And I'm going to draw 1. And let's see what happens to the total. When I draw a ball out of this box, it says it's not replaced. That means I take the ball out and I don't put it back in. I put it out here. So that means that when it's not replaced, the total balls gets decreased by 1 because you take it out of the box and you put it to the side. Okay? So that's important. So our denominator, our total, is 9. But it's gonna go down by 1 when you take a ball out. So right now we have 9, but in a second when I take a ball out, there's only going to be 8 balls in there. Okay? Then it says a second ball is drawn at random from the box. And it does not say it gets put back in. So what happens to the total again? It goes down by 1 again. And the reason it goes down by 1 is because it says not replaced. That's when our totals have to go down by 1. Okay, let's keep reading. It says draw a tree diagram for this experiment and find the probability of the event that the 2 balls are the same color. Okay, so we got our balls. So here I am. I have a box in my hand, and I'm gonna take a ball out of that box, okay? And this is my first draw. Okay, so when I pull this ball out of the box, it could go 2 ways. I could go white or black. I could pull out a white or a black ball. Let's find the probability of pulling out a white ball. We already know. How many white balls are there total? There's 5. And there's 9 total balls. Okay, well, the probability of getting a white ball is the part over the total. So there's 5 white balls, so 5 over the total, 9. Okay, the probability of getting a black ball is 4, because there's 4 black balls, over 9. So that's my first draw. But after this, I draw a second ball. So then I have a second ball that I pull from this box. And that second ball that I pull from the box it could be white or black again. Oops. Either way, white or black. Okay, so this top branch of 5 over 9 means that the probability of getting a white. So if we pull a white ball, we follow this top path. If we pull a black ball, we follow this bottom path. Okay, so this first branch means we could have either pulled a white or a black on our first draw. Then, when it's time to draw my second ball, I could either pull a white or a black. Okay, so let's see here. If I'm just following this top sucker, this top path, let's see. My totals have to go down by 1. Because if I pull a ball out of this box, I no longer have 9. because now one is sitting to the side. Now I only have 8 balls in my box. So my denominators are 8. 8. Okay, now let's think about this. How many balls did we start with? We started with 5 white balls and 4 black balls. Okay, well, if we follow this path, on my first draw, I pull out a white. That's what this W means. I pull out a white. Well, if I pull out a white, how many are left inside? So if I have 4 whites and 5 blacks in my box, and I'm following this top path, if I pull a white out, how many do I have left? I have 3 whites and 1, 2, 3, 4. I'm missing a black. No, I'm missing a white. Shoot. I'm missing a white. Anyway, okay, that was a bust. Okay. Anyway, the point is, if I pull out a white ball, I'm not going to have 5 whites anymore. I'm going to have 4 whites. So if you pull a white ball out on this first draw, we're not going to have 5 whites anymore. Now we're going to have 1 less, which is 4. Okay, well, let's say if I pull out this white ball, does it affect how many blacks are inside? So no, it doesn't. If I pull a white on my first draw, that means that there's still 4 blacks because I haven't touched it. So on my second draw, the totals go down by 1 because I pulled a ball out and I did not replace it. So that's where the 8s come from. The reason the probability for the white goes down is because if you pull a white ball, you do not have 5 white balls left. You only have 4. The reason the balls for the black stayed the same is because if I pulled a white ball, the black balls stay the same amount, as in 4. Okay, let's look at this second path. This second path says, hey, I pulled a black ball out. Okay, well, if you pulled a black ball out and you do not replace it, that means the denominator, the total, goes down by 1. So our totals are not 9 anymore, they're 8. Our totals are not 9 anymore, they're 8. Okay, well, let's think about this. If you pull a black, that means there's 1 less black ball. So if we started with 4 blacks and we pulled 1 out, that means there's just 3. Okay, well, what about the white balls? Well, on my first draw, all I did was pull a black. Nothing happened to the whites. So the whites is still the number 5. Okay, so here's our tree diagram. And the numbers from this first draw and the second draw are different because the totals go down from a 9 total to 8 totals. 9 to 8s. Then in the second draw, whatever you pulled goes down by 1. So if I pull a white on this first draw, that means this white number 5 has to go down by 1 to a 4. Whereas if you pull a black, your black total has to go down by 1 to this 3. Okay, then it says draw a tree diagram. We did that. And find the probability of the event that 2 balls are the same color. Okay, well, first we have to figure out all of our outcomes. So my first draw is this right here. My second draw is this right here. Then I'm going to write down all the possibilities. Okay, so this is where we follow the path. You follow the branch. Let's look at this top guy. I could pull a white and then white, white, white. Or what does this bottom branch signify? This bottom branch signifies white first, then black. You follow the path. Let's look at this guy. Let's say I pull a black and then I follow this path. Well, what are these? These are black, white. So that possibility would be black, white. What's this last path? We follow the B, then we follow the B again, so it's BB. All right. So, how many, or first let's see, it says find the probability of the event that the two balls are of the same color. So, same color is this WW and BB, because that means white, white, black, black. Okay, now to find the probability of this white, white, you have to multiply along your path. So let's look at the white, white path and find the two numbers. White, white, 5/9, 4/8. Let's write that down. 5/9 times 4/8. Okay? Now let's find the probabilities for black, black. Well, if you pull a black on your first try, it's 4/9. If you pull a black on your second try, so we pulled black first, then we pulled black second, 3/8. So let's go over that again. This white, white, that means I pulled white first, 5/9, then another white, 4/8. Black, black means I pulled black first, so not any of this hoopla. I have to look at the first branch to be black. Okay, then the second branch, black, those numbers are 4, 9, and 3, 8. So I wrote this down. Okay, so we multiply along the paths. That's what those little dots are for. Then it says add probabilities of different outcomes together. So these are different outcomes. White, white, black, black. So we're going to add those. Okay, now let's remember how to multiply and add fractions. You go left to right. So to multiply these fractions, you do 5 times 4 and 9 times 8. 5 times 4 is 20. 9 times 8 is 72. You can use a calculator. I encourage it. Okay, then on this other sucker, 4 times 3 is 12 over 72. Now the bottoms of my fractions are the same, so I can add the tops, and you get 32, but you keep the bottom, 72. Okay, now we're going to try and reduce this. I think you can reduce it by 8. That means divide every piece by 8. So 32 divided by 8 is 4. 72 divided by 8 is 9. Yeah. So my combined probability is 4/9. Or if they let us put in a percent, we could say 4 divide 9 is 0.4444444 if they tell us to use a decimal. And you'll have to figure out, you'll have to read what they want you to round to. Okay,